if it's streaming. I did some things off stream, but I can see that I'm gonna have to do a lot more things because I was looking into the UPI and it's gonna be a challenge, I think, to translate the stuff. I realized that as well after I did the things I did so far that it might not be the optimal way based on what I want to do. But so far I created this loop here that takes all the hands that were saved in the JSON file based on the patterns of the string of the hands of the data. So I'm looping, then I get all the hands, then here I get the amount of rounds that exist in each hand, and if there is less than 2 rounds, I think, so less or equal to 3, then it continues because then it doesn't have a flop if it doesn't have the round 2, which starts with 0, so it's length 3. And then here I made this class called sim. I was gonna do a class called player, but then I realized that it's better to do the sim class, and then the way that I'm thinking about it is building the whole sim on each iteration of the hand. But I think I'm gonna change this after. But it's good that I did it like this because then I have the option as well to create based on data, create one simulation for each hand. But that's the reason why I'm thinking to change, because I think that it's probably better to not do that and to get the most frequent bats possible. So I'm thinking about creating a different script that gets all the boards and then connects all the boards with all the most used bats. Because what I want to do is not necessarily place for each simulation, the way that I'm doing here, I'm going to put only the bats that I did on the hand and that they did on the hand. And that's not going to be very good because ideally you want to have multiple different bats, and then after you solve the simulation, then you node lock for them only betting on certain amounts, because then that allows you to have a greater understanding of what their imbalances are. So the whole point of doing this stuff is to get the data and to use the data to see what are the imbalances in the pool when they play against me, and to know what the solver response is against that imbalance. And also to study my own imbalances as well, because I'm gonna do the same thing with my bet sizes. So put different bet sizes than the ones that I'm used most often and see like what I can improve, what different sizes I can use on each street. But the way that I'm doing here, I'm just putting the bets that were playing the hand on the sim. And the other thing that I did here and that I realized is that it's much better to just leave multi-way pots out of the way, and also to skip hands that were folded by me in pre-flop, because those hands so I think they are useful for data analysis, but they are not very useful to build simulations, because simulations only allow you, at least with Pio, only allow you to put 2 players. So it doesn't make sense to check the hands that are multi-way, that have more than 2 players, or the hands that are folded pre-flop, because then there is no flop. So but here I'm building the sim, then I initialize the spot size to 0, which is the thing that I'm going to use here, the starting pots, and then the action 0 is posting the blind, so I have to increase the size of the pots with this. And I also couldn't find a way to, because I'm going to have to do some nested for loops on this simulation here, and I didn't find a way to make it more efficient yet. It's very inefficient. So let me show the sim class maybe first before I go deeper on this. So here, this stuff I didn't use. Not sure. Oh, I think I'm gonna use that. I'm gonna have to do the tree structure when I'm converting the bats that I get from, because the way that it builds here, and this is what I mean that I think it's going to be very hard. The way that you build the tree, you have to put the Z line here, but the way this format, I don't understand why they did it like this, but it's gonna be a pain in the ass to build the tree, because you have to put all possible combinations of bats, and you have to keep in mind that it's gonna be cumulative. And so here, like it's saying that it checks, then one player bats, then it calls, but the number is the same after it calls. And then they both check, and the number is the same as well. And then only increases in the river when someone bats. So this is going to be really annoying, because I can already tell like how I'm going to translate all the bats that I have, and then I'm going to have to think about getting all of the possible actions on each street, while keeping in mind that the numbers are going to be like this, where sometimes they're going to be the same, sometimes they're not going to be. So the thing that I'm thinking about doing is just creating a tree structure. But even if you create a tree structure, then the problem is that it might get like really massive. I don't know how they do it. Oh, they have the raise sizes actually. But here it only shows the raise sizes one time. It doesn't show the tree bat sizes. So that's the thing. So what I'm thinking about doing is just making a random tree here and then saving that. You can save here, and then I look at the file and see like the formatting. And also what I'm thinking about doing is the other way around now, where I'm not going to use the simulation. I'm going to do data analysis to see what are the most frequent bat sizes and what. So not sure if tree structure is the best, but create a relationship between the board and the bat sizes that are used most often. It's probably a dictionary is better, where for each board I'm capturing the bats that they did on the board for flop, turn, and river. So it's going to be a nested dictionary, I think. Here I'm doing this flop, turn, and river. So I'm probably going to put these things here on another dictionary, and that's going to be the board. The key is going to be the board, and then the values of the key is going to be the board, and the value of the board is going to be a dictionary that contains these keys here and the bats. So it's going to be a nested dictionary with this arrays here, I think. And then with that, I can know what sizes are going to be used the most for them, and then I can add additional sizes as well. And then instead of building the tree, like creating an algorithm to build all the possible bats, I place their bats and the bats that I think that are going to be good to put here. And then I save the tree, and then I get the parameters to build with to automate the building process. I think that's both easier to do and more efficient to what I'm trying to do. And then for node locking is probably getting the frequency that they show up in the river, and then decreasing that, or increasing from the frequency that the solver shows after I have the simulations that of the hands solved, which is also going to be challenging. But here I have starting points. I made a list of what kind of things I needed for, let me put 1 hour and a half here, for building the simulation, and that's what I did here. So starting point, effective stack, the positions, which player is in position, which is out of position, then the hero range and villain range, and then here is all the bats. And V is for villain, and the others are my bats. And then this function here I did with the help of ChatGPT, which is a function that I pass the previous bats that were made on each round, and then it figures out if it was a call, raise, or a fold. So here this reverses the array, the array of previous bats. Then it stops on the first one to get the last bat. And this was very confusing to do. Like the other functions were really hard to do as well. And this is the function that I'm not sure if there's any better, because each time that for each action on this file here, on this, not this file actually, because I put the function here as well, but for each action they do on each round, I have to pass the previous bets here. So I'm doing an extra loop. Obviously the loop is not gonna be bad because it's only one iteration that is gonna go, because I'm only passing previous bets, I'm not passing checks, if I remember correctly. But let's say I'm passing checks as well. Then obviously the worst case is gonna be that it runs the whole loop over and over again for each action. But I couldn't think about a way to do it that doesn't do it like that. Because how are you gonna know if if it's a bet or a raise if you don't have access to the previous actions? So the only way to know is to look into the previous actions and then classify based on that. But I think that this is not too bad, because the tree is not going to be very big. The amount of bets that exists here are not going to be very big, because it is the bets for each round after the flop. So, and since there's only 2 players, the list is not going to be very big. So it's not really bad, but it's not ideal either. And it's very hard to think about a way that doesn't require that I can use maybe the action number to do it. Yeah, I couldn't maybe create a cache with the action number outside. I don't know. But I think I'm gonna leave it like this, since I'm probably not gonna do it this way that I'm showing here. I'm gonna do it the other way, right, with the data analysis, and then just building based off the bets. Just the previous bet or raise amount. Then I get the current sum, the current bet or raise. If it's less or equal, then it means it's a call, because there are situations where you might get a 3-bet and then call. And then in that case, the value is going to be lower than the previous bet, because you're just calling the amount that is. Let's say you bet 50, they increase for 1, you're paying 50 only. So you're getting a lower value. And then if it's bigger, then it's a raise, and if neither, then it's a bet. And then in each case I append to the specific, I check to see if I pass the player in the street. And then if it's me, then I put in my stuff here, and if it's not, then I put it on the villains. And for each street, and so on. And then this function is to check. This is for, I made this function for pre-flop, to check if the hand is multi-way or if I folded. And also here I was thinking about that I needed to classify if it's a single raise pot or 3-bet pot or 4-bet pot and so on. And then I made some stuff to figure that out, but then I realized that it's not necessary. The only thing that I need to know is if they're in position or out of position. So it doesn't matter which kind of pot it is, because I have the effective stack size and the pot size, which are the only things. So usually the way you build simulations, you separate into 3-bet pots and 2-bet pots, which are single raise pots. And the reason you do that is because of the starting pot and the effective stack. They are different. But since because obviously there's going to be a higher starting pot when it's 3-bet and lower effective stack. But since I'm using real data here, like I can get the starting chips for each player, and I can get the pot size by keeping in the way that I did here, like initializing the beginning, and then I add all the bets that were made up until the flop. And so here I'm using this to see how many players exist on each hand. So I'm looping over the bets, and then I get the sum. Looping over the actions, get the sum of the bets. If it's greater than 0, then it's a bet. Then if the player is not on the cache, I put, and the player is not hero, because I only want to put players that played against me. Then I make this equals, I create the player on the cache here, then I append the previous bet to the sum, which I'm gonna use later, I think. Ended up not using. I was using this to, maybe I can remove. I was using to call the other function previously and pass the previous bets. But now I realize that I'm not using this, so I probably can remove. Yeah, I think I can remove this. But if the action is 0 and then is made, then return 0 because I didn't play the hand. And if the action is 0, so the player checked, and the player is on the... So this is the situation where I thought about, where... Because initially I was doing only up to... I was tracking up to 2 players if they are on the cache. And if there are 2 players on the cache, that means that it is a multi-way pot. Because obviously it's gonna be me and then the extra 2. But the problem with that is that, let's say I bet, then someone calls, and the other player raises, and then I call, but the other one folds. So in that case, it's still 1v1, but in the way that I'm doing here, I wouldn't catch that scenario. So that's the reason why I did this check here. Because if they are already there, but now is a 0, it means that they folded, so I delete them from the cache again. And then at the end, I check to see if it's different than the values that exist on this thing, because then it's a multi-way pot. So I think I'm gonna remove this previous bats because I'm not using it anymore. I was using that to call this function here because I thought that I needed to figure out if it's 3-bet or single-raise bots. Oh no, I'm using here, that's why. So yeah, I'm using this to get all the... increase the size of the starting pots at the outside of the function. Because I call the function here, and then I increase the size of the pots based on the value that I received there. Because here I have all the bets that were done pre-flop. That's why I have there. And then here I get the first value of the cache to return the player name, because I'm gonna need on this function here, which is the function that decides whether or not each player is in position. And I'm not 100% sure about this function, but I as far as I can think in my head of all possible scenarios, it works fine. So first I update the viewer position and villain position based on the stuff that I did outside. So I call the multi-way check here to see if it is. If it returns 0, it means that it's multi-way or folded, so I continue, which goes into the next iteration of the loop. So if not, this is going to be 0, then this is going to be true, and it's going to continue and go to the next iteration of the loop. Then I increase the pot of the pot size based on the bets. Then here I have to loop again over the players to get the hero position and the stack, and the villain position and stack as well. And then I update them here. And then I call the other function with the positions and the name of the villain. And then here I created a dictionary, and this is pretty much it's like ranking the positions based on who's gonna act first pre-flop. And then I made this check here where if the hero position is greater based on this dictionary here than villain position, then it means that hero is in position. And as far as I can think, that any situation, regardless of whether or not it's 3-bet or single-raise pot, it works out because it's based on post-flop. So it doesn't matter what happened before, but I'm not sure if I thought about all the possible situations. And that's the challenging thing, because there's so many different things that can happen that it's hard to think about how to code something that is going to work for all of the possible situations. It was very challenging to think about this stuff. But then, yeah, this figures out whether or not they are in position or out of position. Then I initialize the pot size and the effective stack on the seam, which is going to be the minimum of the hero stack or villain stack because that's the effective one. And then here I create this other function to get all the bats and raises from the round, which is this one. So that's the thing that I mean with that I'm gonna have to do nested for loops, because here I'm looping through the actions, then I have to keep track of the previous bats on here, and then I have to call this function, which is gonna loop again. This is what I mean, that I'm not sure like if there's a way to improve this, because then I'm looping over each one, and then I'm passing them here, and then is looping again to see all of the previous actions and to classify the current action to see if it's a raise, bat, or call, to append on all the possible bats there on flop, turn, and river. And I pretty much call this function for all the different rounds, making the check here to see if there is a turn and river, because the flop I made the check in the beginning, and the reason why is obviously so it saves time on calculating everything else. Yeah, so here I check to see if it's index 0, which means it's the first iteration. And here's for the donk bats, because if the index is 0 and the player's out of position and the current sum is more than 0, then it's going to be a donk bat. And then I append. And here I'm thinking about that I should do another condition here, because this is gonna check twice. That's the problem. Yeah, so I should put else here, and then just copy this stuff and put here. And then here I put else. Yeah, now I think it's correct, because here was checking twice. And then I append the bat to the previous action, to which could be a check to the previous actions. I'm not really sure if I should append only if it is a bat or not. Yeah, but it's very complicated. So I don't think I'm gonna spend a lot of time on this one anymore. I think this can be useful, like I said, because anytime that I want to, like, it might be worth it to think about how to translate, which I think I'm gonna do anyway. So I'm gonna create an algorithm that translates this structure here into the bat sizes, I think, into the lines to add on the solver. So now what I'm gonna do is figure out how to build a simulation. So let me do one different bat for each one, because that way I'm gonna know which thing is where. I think I'm gonna build the simple simulation, and then I'm gonna save the parameters and then check for. And so the challenging part is gonna be translating this data structure from the class into the lines. So getting the bats and this is the stuff I think is better to run to see how to build a simple simulation first. I just copy the one that I have here and build it. And then based on that, I think about, because it might be that is better to, instead of using this data structure here, to do something else. And thinking about it now, I think that was a mistake as well. I should have started with building the simulation first. But I was just curious to see, like I wanted to manipulate the data, because that's very interesting, obviously, to see what kind of bats and things like that. So that's why I started with parsing the data. But it would have been better if I just did the simulation first, so that way I would be able to know like what would be the best way to structure the data in the beginning, so I can build a line with Pile. I'm just putting a random value here that is different for each one. There isn't 55. It's probably 65 is better. But that's the problem. So let me do 90. 100. Yeah, so now I save this. It will be in tree building. Building. Yeah, so it looks like the range is 0 and the range 1 are dictionaries that contain the cards. And that's the other thing I'm gonna have to do probably, is if I don't have enough data to reverse engineer their hands based on showdown for each position for the pre-flop, then I'm gonna have to also add some hands as well. That one I'm really curious to see what's gonna show. I'm guessing that it's gonna be very, very different than what each people, based on simulations, based on GTO, what each people is supposed to play. Also, it should be a good idea to get the bet sizes as well. For building the ranges pre-flop. That's the reason why I do need to separate into single raise pot 3 bets on the other one, because for pre-flop, because of the ranges. But I know a way to do it that is easy to classify what's the, and it's based on this function as well, the get decision. The way that I did it, I just put single raise pot here equals 0, and then 3 bet pots. And initially I made 3 bet, 5 bet, 4 bet, 5 bet, but then I realized that I can use only 3 bet. And then based on the amount of raises here, if there's one bet, I increase to single raise pot to 1. And if there are raises, then I increase 3 bet to 1, because at the moment someone raises pre-flop, then it means that it is a 3 bet pot. And then for each subsequent raise, you just increase the size of the 3 bets. Because obviously the other actions are going to be call because of the logic here. And then you make the conditions to see Like if the actually I made false here, I think, but it doesn't matter because the moment is true or greater than 0, it doesn't matter. You can just check to see if this is true, and if this is false, then it's a single raise pot, and then otherwise you just get based on the number here, where each raise increase the number, and then you make the conditions to see if for 3-bet, 4-bet. It's not hard to do it, but I think I'm gonna have to do that, and I'm gonna have to restructure this function. But I'm probably gonna I'm not gonna leave this one alone, and I'm gonna do another file where for these different types of simulations that I'm thinking about doing. Oh, so here is the thing, because the ranges here are showed like this, but then I think I need to format them like this, and that's the issue. Because it's not clear here. That's the problem I have. Like, and the documentation doesn't explain this stuff. Because it obviously would be much easier to format things this way, but it looks like you need to format it this way. So how I'm gonna translate this stuff into here if I don't know the sequence? That's the problem. I guess I can make made up ranges as well, just to, but it's still annoying. So I'm thinking that it's probably gonna be, I'm probably gonna have like the other functions I'm gonna do with a dictionary, the other format, these ones, because it's easier obviously, and I'm just gonna get all the possible combinations. Here is doing A9 off or S, but then if you have different suits, then it's gonna specify that here as well. So I'm gonna do it with the different suits. Or maybe yeah, it's probably better if I put all the possible variations actually. So do it in this way and do it with the specific suits as well. But then it gets more complicated because the moment you have suits, you have to reduce from the other ones. But I'm probably gonna do with specifying each suit on the thing. And then from this dictionary, I'm gonna have to think about an algorithm that translates this dictionary of frequencies based on the hands into this thing here. It's gonna be really annoying to do. So it looks like, yeah, it looks like this is all comments, so it doesn't matter. And the actual commands are set range, then set bar, set effective stack, set isomorphism. I'm not really sure what this is about. I think it's, yeah, I don't know. Obviously something to do with GTO. I don't, what is isomorphism? It's something to do with the permutations. Poker hands show from a tight set of indices. So I think that this is probably the values of the matrix here, of the range. I just have to think, I have to see which one is the starting one. But the problem is the frequency, because the issue is I don't know if it specifies suits, if it's gonna change the sequence that you need here. That's the problem. Subbarns. The rest of the commands are obviously the easiest ones, I think. I also don't know why setpot has 3 different arguments. If it's just one here, that doesn't make a lot of sense for me. And the thing is that it's not explained on the documentation. That's what makes it harder. I don't know why it's 3 different. I guess I can just save just change the file and then see what happens. So put 30 here. And then go here. And it's still the same. Maybe I have to close the file and open again. Yeah, it's still the same thing. So I'm not sure what this changes. I'm gonna leave it like 0 for all of them. And this is the part that is gonna be annoying as hell. So I'm going to translate the values into this. They must have an algorithm for doing that, obviously, but it's hard to think about. And here the values are all different because it's the whole thing about cumulative bets, I think. So the question is how do I test this? One thing I can do is build a bunch of different bet sizes and then build a bunch and then save and then store them, like create a hash or maybe not a hash, but just write down on the IDE the bets that I choose and then write down this equivalent format for them, and then I do a bunch of them and then I figure out the pattern based on that. Like what is the stuff that is changing and what it isn't. So if I do it enough times, then I don't need to know all the lines. I can just use this template here and then just change the template based on the data. But the other way that I'm thinking about that is going to be a lot easier is the other way that I talked about in the beginning, which is to just get the build. I'm going to build simple functions that get the bets that are used most often, and I'm going to build the simulations based on that. But the thing is that the problem with this stuff is that I'm not going to show on stream, I think, because I don't want to reveal the bets that were used most often on the thing. So I think I'm probably going to stop doing this maybe after today or after next time, because I want to build obviously I don't want to show the data, I think. Maybe I will change my mind and then show it later, but I think that it's probably better to not show and just keep it to myself, the actual data that is used there. But that's what I'm probably gonna do, just create this function here similar to the one that I did here. I think I did it on this file. So I'm going to use this file and I'm going to do something similar to what I did here with this counter. So here I'm getting the frequency of flops, of boards. So yeah, I should split this as well. Split and join. So I'm gonna get all the flops, and for each flop I'm gonna get the hands, not the hands, the bats that were made. And I think I can just call the function that are the functions that I built already. To put each hand on each bat on the specific thing. And so I'm gonna do something similar to what I've done already. And so this is gonna be true. I need to check first. And so I'm probably gonna get the index after, because it might be the case that it doesn't have the flop. It doesn't have a board, so. But I'm gonna use the same functions that I used to get the bats on the format there. Yeah. On this format, and then I'm gonna, after I get the bats, I'm gonna save them to a file, I think, the ones that are used most often for each board. And then I use that to build the simulations. And also the starting pots and the effective stack as well. So I'm not gonna use only that. I'm also gonna put other bat sizes here that I think make sense and that people might not use all the time. So then I can see their mistakes. And after building the simulation, also thinking about the no lock. Let's see what ChatGPT answered. Iterate through each hand in the dictionary, calculate the percentage frequency of the hand by dividing its frequency by the total frequency. All hands in the dictionary. Oh, the other thing that I have to do is to make some calculation to change the bats, which is gonna be annoying as well. Because I have to change the bats into percentages of the pots. But I think I can do that after I have all the bats for the flop. Let me think. Pre-flop, I'm not putting any bats there. So, yeah, after I have the pot size. Yeah, but that's also an issue. I forgot about this. Because in this function here, I need to increase, not this one. I am doing this on this one. I need to do it on this one. Yeah. So I need to get the sum of these previous actions on this one. Because for each bet, then it's going to change the pot, it's going to change the percentage. So in this function, I'm probably going to do some calculation that changes the bet sizes to be a percentage of the pot size. So I'm probably going to have to accept the pot size here and then change the pot size based on that. And then return this pot size. Maybe I don't need to return. I need to return so I can increase on this thing here. Because for each one I'm calling this, so should return here and then increase to the overall pot size. And so I am gonna do a merge of the two because a lot of the stuff I'm gonna need again from this stuff that I did here just to calculate the bet sizes. But instead of looping through all the hands, then I do this looping here, and then I structure the information here. It's probably better to do it like this. I think I'll be right back. I'm back. So I think it's not worth it to show the data on stream because it's worth money. I think I have a lot of hands here. I'm not sure if this is correct or not, because I think I didn't play that many hands. So there might be something wrong here with the way that I did this. But I think with certainty that there's probably at least 300,000 hands here. And which means that's like, it's a lot of hands. So, and also, I don't think that I should give this information for free. But I'm gonna build the functions probably here on stream, and then I'll do the rest off stream. But I'll think about it. Maybe I'll show and whatever. So what I want to do here is to create the link between the bards and the bats for each one. And so this works, I think. But I'm getting only... There's something wrong with this, I think. It's gonna be a pain in the ass to change the letters as well. I don't know why some of them are only getting one card and the other ones I'm getting the 3 cards and some I'm getting 2. Because the way that I added here, it should be the flop added first and then the turn in the river based on the... Where is the function? Based on the way that I did here. And because the flop is always gonna be first, so... Should be adding the flop, then the turn, and then the river. Which means the flop would be at the end. Thinking whether or not it's worth it to change this part here to get a different format in there, but I think I can think about a way that it would be better than this one. Maybe if I separate, but then it's just a lot, it gets way more complicated. If you separate by flop, turn, and river. Oh, actually, maybe I can put it on a list instead of making a string, and then I append to the list each time. Yeah, that's actually a good solution, I think. And it's better because then it's going to be easier to distinguish. Also not 100% sure if this only gets is only getting the card. I think it is, but not 100% sure. I think maybe if I change this. I think I'm gonna leave it like this and see what happens. Yeah, so that way I pan them on different times, and then at the end it's gonna be a list with the... So the first element in the list is gonna be the flop. So yeah, I'm gonna leave it like this so that it doesn't fuck up the one that I already have in case it goes wrong. But I don't see why it wouldn't. Why it wouldn't work. Yeah, so this should be a dictionary, I think. And then in the dictionary, I'm gonna do the same thing that I did there. Yeah, I think I have to separate between the villain bats. The problem is with doing like this is that I actually... It's gonna be better if I just... Yeah, I have to think about a way to add the information here. Because I want to use this thing here because obviously the functions that I built here are all based on the class. So if I just get the specific function and then that adds this function here that adds the bats here, and then I put the format there, then it doesn't work because it's not part of the class. So I think it's better if I use this and then I get the bats from this function and then I update the other one. I update here based on the other one. Yeah, then I can just add flop and then make it equal to sim.flop for each one. So I'm trying to think what are the things that are going to be different from the two of them. On this one, the only thing that I want to get is the relationship between boards. Oh yeah, I'm going to have to put the values of the boards. So it is different. So it's going to be, the keys are going to be the flops, the boards of the flop, and then the value is going to be this structure here for each one. It's going to be a dictionary with this structure. Because for each flop, I want to get all the bats. So I should probably work first on translating these bats here into a percentage of the pots. The other thing I can do is just change based on the class. Not sure which one is better. So I can just use the sim starting pot. The self.starting pot. it's difficult to know because I don't know. It's hard to think about all the possible applications. Obviously, if I use the self.starting pot here, then it's good because I don't have to pass as an argument, but then the problem is that it gets entangled with the class. So it depends on the stuff that I want to do outside of the class. Because then later on, I might have a situation where I don't want the starting pot to be based on everything that this class has. But I think I can just use the class, so I'm just gonna use self.starting pot. And I have to check first here. So maybe create another function to transform. I'm gonna have to think about the rule of 3 to translate one into the other. And then string followed by its frequency is that one. I think it didn't understand what I want to do. So I'm gonna get this. Actually, it's better if I just get to the hand. So annoying. The thing is, I don't know which one is which as well, because there is range 0 and range 1, so I don't know which one is out of position and which one is in position. And maybe I should focus on this later, because otherwise I'm gonna get confused. This is better to focus on this stuff first. Here, I think I'm gonna get another. I'm gonna make another function here. And I need to calculate, I think, before I do. Before I check for the dunk paths. Let me think. So let's say the pot's 100%. About 30 is going to be 30%, obviously. Yeah, so it's the amount they bet times the pot divided by 100. Amount they bet times the. Maybe there is an issue with doing it like this. I think it's better if I pass it as an argument. Because then, if I'm gonna use this for building the simulation at the end, it needs to be with the bots that I'm gonna do it passing. I think it's better. So divided by 100. But I think this has to be an integer, so I'll do integer division maybe. No, pot is int, but yeah, the lines, but maybe it accepts, it doesn't say anything that it doesn't accept broken numbers, like float numbers. So I'll leave it like this and then I will change later. If it doesn't work, I'll do integer division. The main thing here is that I don't know if the order is gonna be the same. But obviously I can just test it out as well. You just get this function and then test. Actually, let's do this. Because I can use the example I have. And I can rebuild everything and just change these inputs to see if it works. I'm gonna copy this stuff here. I could just call the function giving the input that I used through ChatGPT. And check to see if it's gonna work when I build another. I'm gonna copy this stuff in another file and then see if the simulation is the same. And then obviously I can do the same thing that I just did, but then change to have suits as well. Not just S and O to represent. So here I would write this into a file, I think. I just forgot how to specify the mode. I think it's file dot right. I think I can use JSON to convert the stuff on a string. First, let me see what it's gonna return. As I think I'm gonna deal with this stuff later once I have all the bats already. Yeah, so it looks like the code is wrong. And then I can use this to debug with ChatGPT as well. But I'm gonna focus on this stuff later, I think. But that's how I'm gonna do it. So I think here is correct. I'm getting the pots, and then I have to put, and I'm gonna have to return the pots as well. Which is pot size. Let me think. Yeah, this is just getting the percentage based on the pots, and then I need to increase. With pots initially, and then each time I increase. Oh, but I have to do before. I'll just use this stuff. Yeah, because the pot size is not going to be a percentage, so just the raw value of the bats. So in each iteration I increase, and then I get the current sum, which is going to be a percentage based on the pot. Just thinking to see, make sure that I'm doing the correct thing. Let's use another example that's not like this, but I'm pretty sure that this is how it works. So 150 is 100%, then 30 will be divided by 5, which is going to be 20%. 320, yeah. Yeah, 3000 divided by, so it is 20. So I think it is correct. Is the size of the no, it's the other way around, yeah. It's the size of the bet times 100 divided by the pot. Now it's correct. And that's going to be the bet in percentage. And I think I can still use this because then it's going to be 0 if it is a check. So anything else is going to be a percentage which is greater than 0. And then I append the percentages. And the other ones is also just going to append. So I think that's enough. Should deal with that. And I don't need to... I'm using previous actions to pass through the function. And then I return here at the end. Return new pot size. And then I use this on these other ones as well. Maybe I should put flop pots. Yeah, maybe I'm missing something, but I think I did everything correct. At the river, I don't need to sum everything because it's gonna be... Oh, maybe not. Actually, now I just realized that I should update. I should use new pot size here as well. Because I have to get the... Yeah, so maybe I should be changing pot directly. Shouldn't even have this variable here. Because after each bet, I need to update the pot size to get the new percentage, I think. Yeah, now it's probably correct. I don't need this as well, I think. So now let me think about this one. I should just print the whole thing actually. First to see. I think it's gonna be the 0 index. So I can just do like this. Yeah, but what I'm trying to do now is the thing about getting the bars, getting the flops, putting the in this dictionary. Oh, yeah, if I have the same board, I think it doesn't matter because what I want to do is get the most frequent bets for each board. So I think, yeah, it makes sense. So if the board is not there, then I put in the dictionary, and if it is, I just append the bets. Or the hard part is gonna be to calculate. It's the other way around. That's weird. And here is also, huh. So maybe there's something wrong with the way that the hands are formatted, like the string. Because doing the way that I did there, you should show the flop always at the 0 index. Yeah, I have to run this again and then see more hands. Where is this thing? Green hands. I think it's because of the way that I'm getting there. I need to change the rejects. But that wouldn't make sense either, I think. Let's here have the flop and then the turn is the hand. So I think it is the rejects the problem. It has to be. Type turn, type river. That should be this thing here. But it does look like it is getting the correct information. Oh, obviously because I'm... Yeah, but the weird thing is that in some situations it's only getting one card. So that's the weird, because you're supposed to be getting at least 3 cards, because the flop is gonna be 3 cards, obviously. And it should put a separate index as well, because each one is a string, I think. So it's like appending 3 different strings into the thing. Yeah, here, for example, like what's up with that? And here as well. The other weird thing is that the flop is in the end. And append, I think, is supposed to... Yeah, so I think it's the way that it is showing here. Because I think the flop are the 3 first ones, probably. So maybe it is correct here. And because the way that is showing there, it looks like the first ones are separate, and then... But it might be just because of the format of the string. Hmm. So it's considering everything as a string, even though I'm appending to the list. And this doesn't make sense to me. It should be a string, but then they should be separate, because I'm not appending to the string, I'm appending to the list. So oh, I'm using the other one. I'm so dumb. So it is correct, but I'm using the wrong data. Well, after I get the boards, then I have to think how to incorporate the class without doing all this stuff. Or maybe I'll do the same stuff that I did on this one. Yeah, now it's correct, so now it makes sense. So let me think. Yeah, what is gonna be the difference between this and the other one? Oh, the difference is that I don't wanna... Yeah, that's the thing. I don't wanna get the bats only for a hero and player. I wanna get all the bats possible. So it's a different thing that I wanna do. So maybe a different... Yeah, but I still need the same format, I think, because... Because I still need all of the bats. Maybe I would do this format, but without the villain bats. I would just put bats. Bats, raises, and dongs. I think that's better. So I'm not gonna use the... My concern is that if I don't use the class, then maybe I just use the class and use the static method. But the other ones I can't. Oh, but the only static method is the multi-way check. Because I want to use this function here, the get decision. I'm not sure. I'm probably gonna need this function because to differentiate which bat is which. But the only difference would be that I wouldn't have the player. So I think I'm gonna copy this function and I'm just gonna use it there. And modify it to not use self and use something else. And then I remove the other stuff as well. Remove the player, I think it's the only thing. So it's gonna be the dictionary. Oh, I had to copy the data. Forgot. And then I just remove this over here. Because since I'm gonna get all the bats possible, it doesn't matter. But maybe I should leave there as well. Because the thing is... Oh, obviously there's a bunch of things that I want to do, so... I can do multiple different variations of the thing. I think it would be good to separate, actually, now that I think about it. Like to put my bats on one place, so I'm gonna do actually the other way. Because although I'm not gonna be separating just by one player, it would still be good to differentiate my bats from everyone else's bats. To see the frequency that all of the other players are using. But then the only difference here is that I don't need to pass the other player. And maybe the other way I didn't need either. But I needed the name of the player in the other situation to see if it's in position or out of position. I think. Yeah, because then I have to initialize just something. Because later on I was thinking about when I build the simulation, I need to have a way to know where the hero is, but I guess I could also use an empty string as well. So maybe it doesn't matter. Like I don't need the villain name to do this. So the only difference is the multi-way check, I think. Yeah, I think that's the only difference. In this situation, the only difference is I'm gonna be putting more bats on the villain bats, because it's gonna be everyone else's bats. The other question though is if I should separate each hand by separate each bat by hand, or just get all the bats based on the streets regardless of the flop. But that I'm not sure how well that would work, because obviously depending on the boards, the bats are going to be different. So I'm contemplating whether or not to use this one and just use the same class. And because then I don't need to call the other functions that require stuff that I'm not going to use. But I think I'm going to use the same class actually. Because now that I think about it, it doesn't matter when they call this function. I can just create... Oh, I had the whole thing the whole time. I can just create the... I can just call this function with an empty string for the player, for the other bats. So I think the main difference between this and the other one... Oh, yeah. I'm gonna be initializing outside. That's the difference. Because I wanna accumulate all of the bats. But then that's the problem. I think I need to renew every time. Yeah, I renew every time, but then the difference is that I'm gonna cache on the boards the bats. So at the end of the whatever logic I put here, I access sim.flop and sim.turn and sim.river, which are gonna be these data structures here. And then I translate them. I check to see if the board exists. Maybe I'll do that in the beginning actually. And then at the end, I'm gonna append the information for all the bats here based on the flop. I should think more about it so that I don't erase the bats on each iteration. But the idea is to have the key as the board, or as the flop. And do I keep track of the Turnham River? That's the other. Should put on the dictionary. I think no, because the only thing that matters is the flop for building the simulation. And then I can investigate. But it would be... Oh, I am gonna have the bats though for the river and the turn. So I think I'm only gonna do the key as the flop, and then do something pretty much very similar to the way that I did here. Just gonna copy this stuff. The only difference is that at the end of this, I'm gonna append to the bard's key to store all the bats. And then I think I'm gonna save those bats into a file, and then I'm gonna use those bats to... Yeah, I'm gonna save the bats to a file, and then I'm gonna use the bats to manually put here. And then I'm gonna add different bats that I think will be interesting as well, and then I'm gonna save the simulation like here. Oh, the other thing that I have to do is the ranges as well. The ranges are gonna be easier because like all I have to do is get the cards. I just can loop through the players and then get the cards of each one on each iteration, and then I can just create a bunch of different lists for each position, and then I just put the cards on the list. And then at the end, I'm gonna have the range, all the hands that people play. Actually, it's gonna have to be a dictionary, I think. So each position is gonna have a list of cards. It's gonna have to be a nested dictionary because I wanna get the frequency. So if a card already exists on the... Yeah, it's gonna be a nested dictionary. Or I could do separate dictionaries as well. So each position is a dictionary that contains the cards and the frequencies. That's the best, probably. So I can create a counter the same way that I did with the board there. So each position is going to be a counter, and then through that I get all the hands that are played through and get the showdown to each position, and I build the range with those hands. Oh, I'm also going to have to classify though, based on the pots as well. Yeah, that's gonna make it harder. So it's gonna end up being similar, I think, to the stuff that I already did. I'm gonna change this thing here as well, so it gives me whether or not it's a single raise pot, 3-bet pot, or something else. And then I can use this function to just see... Yeah, to classify each hand of each player depending on what kind of pot it is. Maybe I think I'm probably gonna have to do another function actually, because not only I'm gonna have to get the pots, like what kind of hand it is, but I'm also gonna need to get their position to know like what hand I'm gonna put here. Because if it's button versus big blind, then it's obviously 2 different ranges. Even though like it might be a 3-bet pots. So 3-bet pots, there's a lot of different positions, so the range has to be based on the position. That's another thing. But I think I'm gonna... maybe I'll do these parts on stream of figuring out the function. To classify the hand and to translate these pocket cards into the range. The thing is, I don't want to show the data though. That's the thing. So that's why I'm thinking about doing all of this stuff off stream. And it's gonna be more difficult than I thought because of all of this nuances of getting the getting the hands type, and then getting the position of each player. And because if I do, a dictionary is going to be ridiculously huge, because I have to take into account I can use either tools, combinations, or products to get all possible combinations of each position versus each position, and then create dictionary based on that, and then create the cards based on that. The problem is that then you have the same situation where I have to exclude multi-way. So it's probably gonna be ended up being the same thing. So I'm gonna have to modify this function here to get the type of hand that it is, and I'm gonna return that with this decision as well. Which means that I'm gonna change the other function that calls this as well. I think here it doesn't matter because I'm not reusing the return. Oh, but it is gonna matter. Yeah, I think. Because I need to get this somehow. What type of hand it is. And I think I'm using this on the pre-flop. I'm just calling. Oh, so this is the multi-way check that I was gonna do this. Yeah, now I remember. I was calling this function from the multi-way check. And it wasn't a static method. And then from the multi-way check, I was getting the type of board that it is. The type of hand that it is. So I think I'm gonna have to do that again. So transform this into, put self here, remove the static method, and then call this function from this one just to get the type. And I can use the previous bats to call the function. So I think actually it's gonna be very similar to them. So maybe I'll end up using this file here anyway. So I thought it would be different because the kind of information that I want to get is different, but or maybe I'll do different ones and then I will separate, because yeah, but the ranges I need to have. Maybe I'll look into the cards first by position, regardless of what kind of board it is, just to have an idea. And then after that, I'll do it like this. Maybe that's a good. I think I'm gonna end up separating and just do the simple stuff here that doesn't require to build the simulation, just to analyze the data. And then on the other one, I format it in a way, I modify these functions here, and then I format in a way that is gonna be, that I'm gonna be able to use for building the simulation. And to get all the bats, now there's other way to think about it as well, which is to not get based on the, which is the easiest way. Maybe that's what I would do, to just get the bats, like all possible bats without any distinction. That obviously would be a lot easier because all I have to do is just loop through the actions and get the sum of the bats, or append the bats to a list based on which round it is. I think that's what I'm gonna do. So the only distinction would be if it is the player's hero or the player's someone else. And then I create two different lists and append all the bats. Yeah, but then maybe I don't need the maybe I don't need to do all the other stuff. I can just do the key value pair that I was talking about and then append the information there. I think that's what I'm gonna do, but I'm gonna do this off stream. And I'm not really sure if I'm gonna continue this on stream. I'm definitely gonna continue this off stream. I'm gonna build everything, but I have to think about whether or not it's worth it to put this information, even though there's not a lot of people watching. But just by making it available, people in the future will be able to come back and look. So I don't know. It's hard to know because obviously I know that this stuff is worth money. The hands and the analysis and this kind of stuff. And it might be worth it in the future to also build something on top of this that I'm going to be able to sell. Like, let's say that I use this stuff to get better results, and then I can just create a page or a website, and then I can create a database of simulations, and then I can automate this process for other people and charge. So I'm not really sure if I'm going to do that or not. I'm thinking that I probably won't do that because I want to do stuff more related to Web3, but there is a chance, I think, that I might do it. So that's the reason why I'm not sure if it's worth to continue this on stream. But I'm definitely going to continue this off stream. And maybe I'll show the simple functions that I did and just explain them. And then, yeah, people that have Pio can use that if they want, can build this stuff if they want. But I'm not sure. So maybe tomorrow I'll come back but I'll talk about something different. I'll talk about Web3 stuff or do something related to Web3 again. And then just finish this stuff off stream. So probably come back tomorrow. Maybe I'll come back today as well.